Hi guys, today we discuss about Azure networking. Typically Azure network diagram like this. So first one resource group. So under the resource group we create virtual network. Under the virtual network we create subnet. Under subnet we create virtual machine. So virtual machine is associated with NIC and subnet we create a network security group also. It's like a firewall. And network security group we can create on subnet as well as NIC. And this NAT gateway will be there. So on public IP address later. So name resolution, Azure DNS and internet like this. So NAT, what is NAT? So NAT is network address translation. NAT is the networking method that changes private IP addresses into public IP addresses. So devices can access the internet. Simple definition: inside your home or company network, devices use private IPs like 192.168.0.1 like that, and 10.1.0.2 or 1. This private IP cannot directly communicate on the internet. So the router or firewall uses NAT to translate them into one public IP. So multiple private IP addresses use only one public IP. So real life example is you have laptop. For laptop we assign 192.168.1.10. Mobile it takes IP address 10.168.1.20. Router public IP 49.205.x like that. When both devices access Google, device send requests using private IPs. Router perform NAT. So multiple private IPs you can access at the same time. So by using NAT, internet sees only the public IP. So even you are accessing multiple users from private IPs, but internet you can see the public IP only 49.205 and .x like that. So many devices can share one internet connection. So private IP we can have multiple devices, right? Like when we are in office network, and so we have many network connections, many laptops, many IP addresses. Those are private IP addresses. So what NAT does is all private IP it link to all private IPs to public IP. Only one public IP. So everyone hit the any Google or any website, public website. So they can only see traffic from the public this public IP only, not private IPs. Why NAT is used? Saves public IP addresses. So suppose if NAT is not there, we have to assign each and every server, each and every laptop, each public IP. So one laptop, 100 we have 100 laptops, 100 private IPs are there. Instead of we have to assign 100 public IPs. So that's why we use NAT. NAT this link to this private IP address is linked to public IP address, one public IP address. Provide basic security also. Allow private networks to access internet. So all private networks can access internet by using only one public IP. Common in home routers and cloud networking. Types of NAT. Static NAT, one private IP to one public IP. Static NAT is like that. Example, we discussed right before. One private IP should be each private IP should be public IP. Public IP. So static NAT is like this. This is one private IP and it assigned to one public IP. Okay, and so used for web servers, mail servers. So when we have web server or mail server, so only we just assign one dedicated address, right? So in that case, we use a static NAT. Dynamic NAT, private IPs use pool of public IPs dynamically. At port address translation, also called NAT overload. Many private IPs share one public IP using different port numbers. Most common in home offices. So now we are using like this setup. Any private IPs share one public IP using different port numbers. So that way it connect all private IPs connect to one public IP, but port numbers will be different. Most common in home offices. So now presently we are using like this simple diagram: laptop 192.168.1.10, mobile 192.168.1.20, router or NAT. So we configure NAT in the router, okay, router or firewall. So only public IP one we face the internet by using this public IP. NAT in Microsoft Azure. In Microsoft Azure, NAT gateway provides outbound internet connectivity. So for outbound, internet, when we connect internet, so by using NAT only we connect. Use it for private virtual machines. So private virtual machines, it combines only one IP. If you have multiple virtual machines also, multiple IPs also, it connects to only one public IP by using that. So every machine will get the internet. Help avoid exposing VMs directly to the internet. So it helps. Yeah, private VMs. If you are accessing any website, right? So private VMs can't be visible. Only public IP only visible there. So easy memory trick. NAT private IP converted to public IP. So we no need to assign multiple public IPs in this case. So NAT is like that. That is all about NAT. And okay, Azure networking. First one is virtual network, also called as VNet. A VNet is a private network in Azure, similar to a traditional on-premises network. So VNet. So we have to create one VNet when we are setting Azure networking. So that VNet we give the address space, and that address space we can use. And also for this VNet we divide as the subnets as per our requirement, and we use that. Key points: IP address range. So IP address range, we can assign the IP address ranges we can partition the IP address. That VNet IP address we can partition as a subnets. That is called CIDR, fully isolated. So when you create VNet, right, and so it won't access to any other tenant. So Azure we call customers as tenants, and so when you create a VNet, right, it is a boundary, so it is security boundary. So no one can access your VNet. So only your company or you only can able to access when you create the VNet. So that create one boundary, and so it won't accessible to any other tenants. So that is called fully isolated. Supports IP version 4 and IP version 6. So VNet supports IP version 4 as well as IP version 6. Presently, we are using IP version 4, and some scenarios companies are using IP version 6 also. Example VNet. Example VNet, how it is like VNet. VNet 10.0.0.0 by 16. This is private IP. So we give IP address like this, and later we'll partition this as a subnets. So CIDR, we discuss about CIDR. CIDR. CIDR is classless interdomain routing. Is a method used to computer networking to allow IP address and manage routing more efficiently than the older class-based systems. What the CIDR means? CIDR replaces the traditional IP addresses classes. We have five classes: A, B, C, D, E. Okay, and ABC we use for public private IPs, and other CD we use for other purposes. So classes with more flexible system. CIDR replaces the traditional IP address classes with more flexible systems. When we use the traditional IP address classes, class A, class B, class C, only we can give some extent of IP addresses only. When using CIDR, we can create subnets, and we can partition, and so we can use many IPs like that. It allows networks to be divided based on need rather than fixed size. When you use directly ABC networks, and so we have to use fixed sizes. But when you use CIDR, it allows the networks to be divided based on need rather than fixed sizes. It's part of the border concept of IP addressing within computer networking. So CIDR notation, CIDR uses format like. So when you are creating subnet, we give like this: 192.168.1.0 by 24. So we call it as CIDR. Like CIDR format is like this. So 192.168.1.0 is the network address. /24 number of bits used for the network portion. So network portion, how many bits we are using? It represents slash after value. It represents here it is /24. So those all are the network portion. This /24 is called the prefix length. It is also called as prefix length. How it works? So an IP address has 32 bits. IP version 4 we have 32 bits only. So 32 bits. CIDR split it into network portion, host portion. Okay. So 32 bits. In 32 bits, CIDR how it divides network portion, host portion. Example /24. First 24 bits network. Last 8 bit is equal to host. So that way it divides. /24 is network, always network bits. Remaining are host bits. That gives 256 total addresses. So host bits, how many? 8 are there, right? 2 to the power of 8 we have to use. So 2 to the power of 8 it becomes 256. I'll show you a calculator. So 2 to the power of 8, 2 to the power of 8 is equal to, it's not giving 1 minute, 2 to the power of 8, 2 square it's giving, right? Okay. So 2 to the power of 8 means 2 into 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 2, 8 times. So it becomes 256. So host bits only we have to power of 2. So then we will get the how many IPs we can in that subnet, how many IPs we can calculate. Why CIDR is important? CIDR solves major problems in networking. So what are the problems it solves is efficient IP allocation. Instead of wasting large blocks of addresses, organization get exactly what they need. Reduce routing table size. Routers can group multiple networks into a single route called route aggregation or supernetting. So it reduces the CIDR, reduce the routers, reduce the routing table size. So if you give more IP addresses, the router table should be high, right? So in this case, it reduces that as well. Flexibility. Networks can be any size, not limited to rigid class boundaries. So normal classes, it gives some C class 256 and B class 65,565. C class, A class, it gives around 6 million IP addresses. But when using when using CIDR, it is a flexibility. Networks can be any size, not limited to rigid class boundaries. So that boundaries we not follow, and we can give any number of hosts that is required for us. Example: suppose a company needs 50 IP addresses. With old classical system, must take 256 class C network. We have to take in old scenarios. Well, classical system with CIDR, you can assign something like slash 26. So slash 26 means 34 minus 26. How many are there? 34 minus 26. It 6, right? So we have to give the 2 to the power of 6. 2 into 2 into 2 into 2 into 2 into 2. 6 times we have to give 64. So host bits we have to calculate. So it becomes 64 addresses. So company only want 50 addresses, right? So if you give slash 26, it becomes to 64. That is fine. Common CIDR blocks. CIDR numbers of IPs. CIDR number of IPs. Suppose if you give slash 32, only single host, single IP only come. If you give slash 30, it comes only 4 IPs. If you give slash 24, it comes 256. If you give slash 16, it gives 65,565, 536. If you give slash 8, 16 millions plus. So in Azure only slash 8 supports, and AWS slash 8 won't support. Okay, and so next one, subnets. So we divide this VNet into subnets. So subnet divides a VNet into smaller segments. So how we discussed, right? Suppose 65,565. Suppose if you take slash 16 network, right? So it gives us 65,565. But in our environment, 65,536 are these IPs are not required at a time. So we'll what we do is subnet. What we do is we divide as a partitions. So like subnet will help us. Subnet divide a VNet into smaller segments. Best practices. Suppose if we have web app and DB servers, separate tiers. So we have to separate web tier, app tier, DB tier, and how many IPs we require. We have to give like that. We have to partition. Reserve space for growth. Okay. Suppose so if you are building 10 web servers, and so in future we may get another 10, like so based on that we have to give the subnet for this. So one subnet per workload type. So any workload like web, QA or prod or anything that workloads, we assign one subnet, and we create VMs in that subnet. So example web subnet 10 10.0 dot 1.0/24. Another one app subnet we create like 10.0.2.0/24. So each subnet will get to 256 addresses because we gave the 2/24, right? So and DB subnet also 10.0.3.0/24. Like that we create the subnets. Network interface NIC. NIC connects Azure VMs to a subnet. So when you create a VM, right, and so each VM associated with an NIC, and so that helps to create subnet. When you create VM, it connect to one subnet, and each VM must it associated with one NIC that helps to connect subnet. Each VM must have at least one NIC compulsory. So if we want to communicate to other VMs, so that should have one NIC and that should have one IP address. At least can have multiple NICs. So one VM, rare scenarios we assign multiple IP addresses. So suppose if you want to create any software firewall or anything, any proxy we have to create. So in that case, we give multiple NICs, but normal scenarios we give only one NIC. Network security group NSG. So it acts like a firewall at subnet or NIC level, controls inbound rules, outbound rules, allow or deny traffic by IP, port, protocol. Example rule: allow TCP 443 from internet, deny all inbound. So what example says is only we are allowing TCP 443. That is the SSL port we are enabling for that particular VM. We are denying all inbound ports. So other ports we are denying. So application security group ASG. Logical grouping of VMs for security rules, easier than managing IPs. Ideal for tier-based security. So application security group, we create one VM we logical grouping of VMs for security rules. For security rules, we create all some VMs. We take some VMs and create logical group and apply security rules on that. So easier than managing IPs. Instead of applying on IPs like NSGs, so we create one rule and so we assign it to multiple VMs. So when creating a application security group, ideal for tier-based security. So suppose if you have any application tier or database tier or web tier, so in that case we create one rule and we will assign it to all that group of VMs. So it will apply on the group of VMs. So these all will discuss in lab sessions also. We will check in lab. We will see in labs, and when we are doing lab, and we can able to see this, and we will discuss about again on these groups and networking technologies when we are doing the lab. Thank you.